by using the Simplex process. Now, instead of renting, what we're going to take a look at is the sample solution that's in your actual project. This is the problem where we have a local dairy who is selling two types of milk, skim and whole. Right? They're not going to exceed 1,000 gallons of milk production per week, and they will produce an average of 500 gallons or maximum of 500 gallons of whole milk, and never more than 650 gallons of skim milk. In addition, production of skim milk will never be more than 100 gallons above the production of whole milk. The price of whole milk per gallon and skim milk $2 per gallon. Okay. How many gallons of each type of milk should the dairy produce to maximize its revenue? So we have a couple of conditions here. The thing we want to do is decisions. Add the number of whole milk and Y the number of skim milk. Now, we have an implied condition here. Because this is a real problem, we know that it cannot be negative. I cannot go ahead and create negative 5 gallons of whole milk. So those are going to be the conditions we start with. They're greater than 0. Right? And our revenue function, $1.50 per gallon for whole and $2 for skim. That was given in our problem, how much each gallon. And we're also going to go ahead and set up our conditions. What you notice is that we're never going to produce more than 1,000 gallons total, so x plus y is 1,000 less than or equal to 1,000. Never more than 500 gallons of whole, 650 of skim, and the other one we looked at was that we're not going to create skim milk will never be more than 100 gallons above the production of whole milk. So whole milk plus 100 will always be less than or equal to that of skim. Okay? So the first thing we have to do before we talk about the Simplex method is we have to get everything solved. Okay? What we have here is called a slack variable. It's really taking up the slack. It's the difference. It allows us to jump between an inequality and an equality. Okay. So we put some slack variables in here. We really are just taking our equation, x plus y, adding a slack variable in, and then putting it equal to 1,000. So it takes up a slack. If the x and the y added together is 900 gallons, well, that's still less than 1,000, but in order to have this be equal to 1,000, we need something to take up the slack of that other missing 100 gallons. So it's going to take up over whatever slack, and the slack variable can be equal to 0. If x plus y is exactly equal to 1,000, the slack variable can be equal to 1,000, or it can be equal to 0. So then we put in another slack variable, a different one for t. For example, if I had 400 gallons of whole milk, well, I need something to be slacked to set this equal. We don't like dealing with inequalities in programming, so we have these slacks to take up the equals. And the last thing I did was I moved the x over to the other side, creating a negative x, added in another slack variable so we can get rid of that inequality and set it up equal to 100. Okay? And so what we really have here is our entire system of equations. Right? X plus y plus x all the way down to the revenue function, which was solved for 0. So we have numbers on the right of all of our equations. Okay? The next thing we're going to do is set up the initial, what's called the tableau, or looking at the actual, it's like setting up a matrix. For example, if we go straight down, the x's, x is 1, 1, there's no x in the third equation, a negative 1x in the fourth, and a negative 150 in the last. So it's really like setting up our matrices, which is how these relate to matrix addition, multiplication, and all the matrix operations. Then we go through and do our y's. Well, it technically doesn't matter what order you do these in. It is common to do the x, the y, kind of going through from the top. X, y, s, I already did x, then I go to t, then y, then I already did y, then u, and then v, and then last r. The next thing I'd like to identify is what's called my basic variables. Basic variables have columns that are all zeros except for one element. And you can notice we have quite a few of them. The first two are out. They have several columns with values in them, but the S, T, U, V, and R are all what we call basic because they're almost all zeros except for one entry. These basic columns actually become a labeling point for my, sorry about that, S, T, U, V, and R. They become a labeling point. Why is it not liking me? For our rows, they become row labels. So the basic variables become the row labels. Put this in an Excel sheet just to keep things straight. I don't want things to get too complicated. So what we want to do is go to the bottom row of our table, and we want to identify the lowest number, the most negative number. So actually the highest value, but the most negative. So that'd be a -2. Okay? This becomes our pivot column. Okay? So we want to determine a pivot row. Okay? What we want to do is look for the smallest value when we divide the answer by the row, or the column, we have determined is the pivot column. So I'm just going to do a little bit of division over here just to show you what I'm doing. I'm dividing 1,000 divided by 1 is 1,000. Then I look over and I have my answer of 500 and the pivot column of 0. Well, that's undefined, so that's out. Undefined values are not okay. 650 divided by 1. I'm dividing the answer by that row. 100 divided by 1. And what you'll notice here is this is the smallest value right here. Okay? It does have to be positive, so if you wanted to do the last one, you could. 0 divided by -2 is 0, but it does have to be a positive number. I'm going to go ahead and dye that red as well. And I guess I'll dye this one blue, just to be consistent with the example you have. Alright, so the pivot row. If the pivot row was a value other than 1, we have to do some division. But since it's not, we can just leave things alone. I'm just going to erase the kind of the scrap work I did. We want to change the entries of the pivot column to 0 using the same method we use in our linear algebra when we go ahead and we reduce this matrix. So it's just like putting a matrix in RAF form, except now we have to be very specific. So what I'm going to do is I look at the opposite of a -2 is a +2. I'm going to multiply +2 times my pivot row of V, add it to R, and that will become my new row R. So +2 times a -1 is a -2.5. And I'm just going to go ahead and change these here. So this becomes a -3.5. -1.5 minus 2 is -3.5. Right? +2 times 1 is +2, -2 becomes 0. That's exactly what we wanted to happen. Now, nothing exciting happens with these columns because +2 times 0 is 0. We add them all up. But here we have +2 times 1 is 2. That becomes a 2. And we'll end here in the answer column. +2 times 100 is 200. Plus 0 gives us a 200. Now what you're going to notice here is that that variable v is no longer basic. It has more than one number in it, but variable y is basic. So we're just going to change that to a v. Alright, we're ready to continue on, but I'm actually going to stop the video and create a part 2 so it does not get too long.